Hey everyone, it's Dr. Walker. Let's look at an example from video 103C on Kepler's law. In this example, we're going to use a third law to calculate the mass of the Sun. We are given the radius of the Earth's orbit. This problem is a plug and chug. We can use Kepler's third law that said that period squared was equal to 4 pi squared over g times mass of the Sun times the radius cubed was proportional to the cube of the radius of the orbit, and we just need to solve for the mass of the Sun in this equation. So when we solve for the mass of the Sun, we're going to get the 4 pi squared r cubed, then we're going to divide by t squared. And then we plug in all the values that we have. We have the radius that is given to us. We have the gravitational constant. We do need the period, the time, right? We know that the time is 365 days. So we do need to do that calculation on the side and figure out, well, how many seconds is that? So to find the time, we can do 365 days. And we can say that there's 24 hours in a day. And then we can say that there are 3,600 seconds in an hour. And that will give us approximately 3.156 times 10 to the 7 seconds in a year, right? That's how long it takes to orbit the Sun. So we plug in all of these values. 4 pi, the radius is given 1.496 times 10 to the 11 meters, divided by 6.67 times 10 to the negative 11 is the gravitational constant, times the time, the period squared. And we will get that the mass of the Sun is 1.99 times 10 to the 30 kilograms. So this is a really cool significance of Kepler's third law. The reason that we know a lot of information about different planets is because we have sent spacecraft in orbit around those planets, and by looking at the size of the orbit of that spacecraft, it gave us information about the planet that was being orbited.